Yep, let's go. So this is 11.5 or 11.6, lines and planes. Okay, that's what that says. Pause the video once I ask this question, try to answer it yourself. What do you need to define a unique line? Okay, either 2 points or 1 point and a slope. Okay, well, we don't have slope in 3D. In 3D we have vectors. Okay, so what are we given here? We're given a point and a vector. So to define a unique line, we have everything we need. And I'll show you how in we're going to be going through the proof really quickly. Trust me, we need the proof for these questions. If we didn't need it, I certainly wouldn't be doing it, but we do. So we're trying. Let's write down what we're trying to find. And while you're taking notes, write it down in a way that you're trying to explain to someone, because when you're reading back on these notes, when you're preparing for an exam or a test, it's like you're a different person reading your notes. I mean, you're literally explaining it to a different version of you that has forgotten this stuff. So trust me and write it down as I say. So this is our point here, and we've just drawn a line through it that is parallel to this line. Okay, so what do we know about parallel lines? Pause the video if you want. So parallel lines, they are what? Scalar multiples of each other. Okay, you're gonna want to write that down. So parallel lines are scalar multiples of each other. And this is going to be important. We're going to use it in the proof, and don't forget it. So given point P sub 0, okay, and we're just going to write it's x sub 0, y sub 0, z sub 0, okay? Trust me, write it down how I do, and it'll make sense. So given point and that point, this is an and sign, and any other point on this line, any other point, because it is the same slope. Don't use that word, but it's you know what I'm saying. It's going to be parallel to this vector. Any other point, let's just say P. I'm going to abbreviate PNT. Any other point, P, and since we didn't do the sub-zero, this is going to be what? Yeah, x, y, z. I know this is a snooze fest, but I promise this is the only section that's going to be sort of a little longer. So if this video isn't 30 minutes, it probably will be the only one that's not. It might be 45, so just bear with me. I promise it'll be okay. Okay, any other point on the line, this line, okay, that we drew, we're going to call it vector L, okay, vector line. So let's write that right here, vector L, so we can refer back to it. This drawing is going to be really essential to understanding how this all works. Okay, so we can say. So what was the question I asked you in the beginning, right? How do we define a unique line? 2 points or 1 point in a vector. Got it? Don't forget that. It'll be quintessential, I would say. So where's this I don't see it in the. Oh, we can write it anywhere. Here, you can write it there. It doesn't matter. Just write it somewhere on that line. Okay, I'm gonna write it right there. It doesn't matter. Trust me on that. So, how do we define this line then? Right? Well, that's easy. We were given 2 points. The first statement, right? Okay, so we can say vector L, this vector, is equal to, right? And pause and try to do this yourself. You know this. Right? Okay. And just think about it. It makes sense. I'm not gonna go into explaining it. It'll take too long. So let this will be referred to as a direction vector. Don't get freaked out. That's just what it's called. It's just a vector. But pay attention to the wording. And the numbers within a direction vector, x, y, z. Those numbers are direction numbers, so don't get freaked out if you see that. Okay, so what was the other thing I said? That parallel. These lines are parallel, right? We have this new line, and then we're given v, and right vector v, which we're given, equals a, b, c. So you're like, how does that help? Okay, they're scalar multiples. What does that even mean? It just means that, and if you know what it means, it's fine. Just skip 5 seconds ahead. It just means that this, whatever that line we are drawing through that point, is going to be some magnitude greater than this, or a scalar greater. So it might be 2 times v, or whatever times v, but it'll be a scalar of it. So how can we use this? Now we have v, and then we have here. So we have a vector here and a vector here. You can write that over it. So since we know parallel lines are scalar multiples of each other, how about we take this guy and this guy. Geez, I should write this in blue so you don't get confused. Okay, we're just dragging these over. So let's write it. V sub L is a scalar multiple of V. So we can just say V sub L equals any number times that V. Let's define that as T. Oh, I hit my foot, stop my toe. Okay, as we're going to know in the future, T is going to stand for time, but don't worry about that for now. Just write it and know it's a scalar of V. You can plug any number into T, so it's not whenever you're solving, you're going to be just plugging random numbers into T to find this shape of the new vector or whatever, just so you know. Okay, we're going to kick it into gear. Pay attention. I'm not going to be looking back as much. Okay, so how do we rewrite this? Alright. So, what did we say this was? This was, I don't know, this point and that point. Okay, so let's write it. P naught P, right? And then that vector sign above it. It's pretty essential. And that thing is equal to T V, right? I'm just making this real simple. Now let's take this, and what is this equal to? Write it down. X minus X naught, comma, Y minus Y naught, comma, Z z minus z naught. I'm saying naught, or it could be 0 sub 0. Z naught and z sub 0, y0, y sub 0. Same. Don't worry about it. Alright. Equals. Now what do you think that's going to look like? Yeah. Probably got it right. I hope you did. A, B, C. Just like Michael Jackson. Wish Michael Jackson was teaching me calculus. That would be real nice. Okay. Alright, so what do you think you would do from here? Alright, you're like, great. So, how does this help us at all? What would you do? Okay, we have this on the outside. Let's distribute it. Let's do that. I'm just writing arrows. I'm not actually going to write it out. Just write arrows and then just say you distributed. And so if these are the vector components and they're equal, right? This is an equal sign. If these are equal, then their vector components have to be equal as well, right? So what that means is, let's write x minus x naught equals a t, right? Because we distributed a t, and this is just coming down right there, okay? Comma, okay? And then do y minus y sub 0 bt, right? And then do the last one, okay? I'm just gonna rearrange this. That's all I'm gonna be doing. Write it out. Keep writing the rest of that, and it's gonna have n parentheses. So I'm just gonna rewrite this because what do we have in a in a given vector? We're given x, y, and z. This looks complicated. It's messy. So let's rewrite it. X equals, right? Because we want x comma y comma 0. I mean comma z. It makes more sense. So x equals what? We're just rearranging that equation. So it's going to be x sub 0 plus a t. Okay, now I'm going to write out the whole thing. You do it too. Y equals y sub 0 plus b t, right? Z equals b sub 0 plus c t, right? I know that looks messy, but I said it out loud, so don't complain too much. Just kidding. Okay, so this is the parametric equation of a line, and it might look familiar because in Calc 2 we did parametric equations of lines too. So you're like, wait, this is the same thing, except in Calc 2 we didn't have the z. So in Calc 2 it was just this and this. Okay, just something, food for thought. Doesn't really matter. Okay, write a star next to it and write parametric equation. Now we have a symmetric equation of a line. That's what's next. And it's just rearranging this formula. So we set, what do we have? What's the common factor? Yep, t, okay? So if we set t equal to, we move all of this junk over here and we set t equal to all that, well, we can do that for that, and we can do it for that, okay? I'm not going to write out the step because you get it. So then we can say that, oh, well, if t equals t, then we could just say that that junk equals that junk equals that junk, right? Write out the steps if, if you, or just do a circle and you'll understand it in your notes. So let's write out what that would be. Okay. Done. Alright, so let's recap. What do we need for a unique vector line? Right, 2 points, or what were we given initially? A point and a vector, right? We only need this point. I know you're thinking, wait, but there's this point, that point in a vector. We're not. Don't worry about it, because look, just follow these steps, and you see it works out. That extra thing is just helping to give us the equation we want. Okay. Okay, what was the other thing? If two vectors are parallel, they are scalar multiples of each other. Okay, and so we have this new equation now. We have two new equations, in fact. This is symmetric equation of a line. This is parametric equation of a line. Okay. So what do we do with them? Well, if actually let's write down an example, and then we can look at these. But basically we can backtrack. So we'll be given a parametric equation as well, and it'll ask, oh, what is the vector and a point on, given from the parametric equation? Just we can backtrack and then. Okay. Yeah. You guys see here. All right. So, so what if you are given a point or a vector such as 1, 0, 3? What could you say about that? That 0 means that that point or vector is going to be lying on the z, or on the zy plane. So just keep that in mind, and that goes for x, y, z. If any of those are 0, just keep that in mind, that they lie on a plane. Okay, so here's an example. That stands for excellence. Okay, find the equation of a line. Of a line, I'm abbreviating, don't freak out. Given, this is a point, -1, -2, -1/2, and it's an and sign. Q, this is another point, okay? So we're only given 2 points. So now you're like, oh well, we can't find an equation of a line, right? What do we need to find a unique line? 2 points and direction vector. Well, how do you find it? We can, you get the point, you see it, right? Yeah. we're gonna do PQ. That's our direction vector, okay? And we can use either one of those points, all right? So that's what we use to solve it, right? PQ, okay? It's like that. And any one of these points, that one or that one, can be that point right there. Okay? Yeah. I'm not going to solve it. I'm just giving examples of the curveballs that will be thrown at us, alright? So you know, just write down how to solve that. We don't actually need to solve it because we get the idea. Okay, so the video cut out, so I'm just going to be explaining what to write down real quick. So next in the video, so write this down. We're given another curveball example. We're given L sub 1 and L sub 2. So those are just two vectors or lines in parametric form, but those are what we're given. Find if L1 is parallel to L2, okay? So that's what you're given. Well, first, to check if they're parallel, see if they're scalar multiples. If they're not, then that means they either intersect or they skew. So I'll be explaining what that means. But basically, we're going to be checking for intersection. How do you check for intersection in a 2D plane with two lines? You set them equal to each other, okay? So if you have vector L1 is x1, y1, z1, and sorry, I burped. You have vector L2, x2, y2, z2. Just set x1 equal to x2, y1 equal to y2. Okay, this is a system of equations. That's how you check for the intersection in a 3D plane. Alright. If they don't intersect, that just means they skew. Okay, so once you set up system equations and you solve it, if all of the numbers are the same, that means they do intersect. Now what do you think it means if, I'm just going to write it out, x1 equals x, y1 equals y. This is a system of equations. z1 equals. So if they all are the same, they intersect. If they aren't, they don't intersect, and that means that they skew. This is called skewing, and it just means that the lines, they aren't parallel, but since it's a 3D plane, they never intersect. They can do that. In a 2D plane, we can't do that, but 3D, they skew. They never intersect. That's how you write it in mathy terms. Now it's going to ask you to find an angle between them if they do intersect. If these numbers equal each other and it doesn't skew, it's going to ask you to find the angle between those two vectors. How do we find the angle between something? Yeah, you got it? Right, cosine. The dot product between the two. Jeez. I know it's a lot. Just stick with me. Alright. Okay, so now you're probably thinking, oh cool, like we're probably almost done, right? We've done lines, and now we're going to do lines and planes. We haven't done planes yet. Planes, not like planes. Yeah. So So now we're doing lines and planes to find it's going to ask us to find the equation of a plane. To do that, you either need 3 points, write this down, you either need 3 points or a point and a vector perpendicular to the plane. Don't get it confused. You probably will, but if you write it down, it'll be more clear, and just repeat it in your head. Those two are different only because for the equation of a plane, you need it to be perpendicular to that plane. So, yeah. This is also called a normal vector. It just means perpendicular. 90 degrees, orthogonal. There's all these different ways of saying it, and it's pretty annoying. Okay. So let's write down what we're given. So we're given a point, right? A point on the plane. Okay, that's really important. Point on the plane. Let's call this, like we did in the last one, let's call it P sub 0. Okay, and do that. Write it out. Y sub 0. Z sub 0. And what was the other part? A vector, but not just any vector. A vector perpendicular to the plane. And let's just write it as N for normal, because that's what it's going to be referred to as. A, B, C, right? Michael Jackson. Alright. So let's where's our picture, right? We have all this stuff and it looks pretty scary, so let's draw a picture. Okay, here's our plane, right? We want the equation of that plane. We're given point on the plane, P0. You know what? Let's do it over here. Why not? Just because we can. It doesn't have to be in the center. Alright? And a vector normal or perpendicular to this plane. Alright? Let's call it N. Alright? And ABC, this is, you can write that out if you want. Okay. So what do we know about these two? So it doesn't really look like we can do much right now, and that's for good reason, because it's just like the last one where we need to pick any point on the plane, just any other arbitrary point. Let's do this one there. It doesn't have to be there because we can translate this anywhere on the plane. This N is just, if it's translated, it's just a scalar multiple of itself. It's always perpendicular to the plane. So it can be wherever we want it to be. P, there. That's the other point. Okay, so let's draw a line through those. Sorry, I drew it through that, but the P, but it's fine. Draw a line between them. What do we know about lines perpendicular to each other? So we have this new line. Camera dead. We're back. So I'm gonna re-explain this because I left off just right there. So we can say this new line we wrote perpendicular to n, right? And this dotted, that's a dot. This is dotted with n equals 0, right? Because just because of the cosine. So write this out in its component form, and this, right? We're given these here, right? Just write them out in their component form. Same thing. We're not changing anything, and equals 0. Okay. Okay. So now that we've written this out, let's just do it. And you know how to do the dot product, so let's just write it out. So you can already see we're just going to distribute it only into its components, right? This is its own little thing here. B, C, okay? So AX minus AX sub 0, right? BY minus BY sub 0, right? Okay. And you just continue that. So you can write that all out. I'm not going to. We're just going to go straight for it. I'm just explaining it. So let's just think about this one in particular. So AX minus AX sub 0 equals 0, right? So if we have that same situation for all of them, let's just take that the minus AX sub 0 for all of them and move them over there. Okay, that's all we're doing. So X, A, you can write AX, whatever. Let's write AX. Plus, right? Because we moved the minuses over there. C, okay, equals, try to finish this if you can. Right, A sorry, C Z not, okay. Right? Did I make any mistakes? No, that's right. Okay. So we can just generalize this part and call it D, alright? So rewrite the equation. Alright, and this right here, that's called general form, and this you're going to want to write this down in red pen. Ladies and gentlemen, ladies and germs, that's about it for this section. Everything else is just pulling from the past sections and throwing curveballs at us. So if you I'm not going to go into I'm not going to solve any equations, but I'm real quick going to show just the questions, trick questions will be asked and how to solve them. So it shouldn't take much longer. We'll just do it real quick. Why not? Okay. So we're given an example. Find equation of a plane with, it's just W slash, it just means with a point. You know it's a point because it doesn't have the vector sign over it. 3, 6, 2. Okay. And yeah. Let me restate this. I think I said it right, but find the equation of a plane with point 362 on it. All right. So we already know that that's one of the things we need. What is the other thing we need? A point and a vector, but not just a vector perpendicular to the plane. Okay. But here's the curveball. Okay, we're given a point and we're given that. So now we're like, what the heck? What is this? We're supposed to find an equation of a plane with this point and that. What is that? Well, it's not a point, because if it was a point or a vector, it would be like, it would have equal signs all over the place and commas in between those equal signs, right? So this, what does this look like? The general form that we just did, okay? So given that, you're gonna have to recognize that this is general form, okay? So we're gonna need that. So, and now you're like, okay, well, how does this help us? In the question it says, and so this is the question prompted: find an equation of a plane with point 362 and parallel to, and then it gives us this. I didn't want to write that part just to give away the fact that this is an equation of a plane. So we're finding a plane parallel to that plane. All right. So let's just use what we know. We know that with general form, just pull out A, B, C, and we have our normal vector, right? 2, 3, -1, right? Okay? Don't overcomplicate it. Yeah. So now you're like, well, okay, we have a normal vector that's perpendicular to this plane, but we need a normal vector perpendicular to that plane. Well, if these planes are in fact parallel, then this normal vector has to be perpendicular to both this plane and the equation of the plane that we will be finding. That's it. And so using that knowledge, what can we do from there? So we're given this point, right, point sub 0, okay? So let's write everything we have. So we have this, we have that, and we have point sub 0. Point sub 0 is point sub 0. So what do you remember from that? We have to get this other p, right? So let's write this out as a vector, right? These are the steps we went through to prove. Okay, and we know that if this vector, right, remember, dot n equals 0, right? Okay. I think you get the point now. We have everything we need, just solve from there. That's how you get the equation of a plane with a point on the plane and it's parallel. This point is on that plane. It's parallel to this plane. Okay. That's it for that one. Whew. All right. This is the last one. I know it's tiring. My shoulder's tired. This is the last trick question. And psych. We're not doing the last one. I can kind of explain it, but it takes so much mental gymnastics. I don't think you'll ever need it or even see it. I hope we don't on the test, because we didn't have for a homework question. But if you want the notes, here it is. Okay, and if you're wondering why the basically you're using component form to find the distance between a point and a plane. Maybe we'll do this, but and yeah, also ignore that. Okay, write that down, make sense of it. I'm not gonna explain it. Okay, bye.